One difficult aspect of the process of software design is finding the right balance between too little design and overemphasis on the design structure. So typically too little design, the lack of design which should be adequate for the proportion of the complexity of our system, just leads to a bunch of compromises and cutting corners, basically thinking that yes, we have some kind of issue or problem, but let's just fix it somehow and make sure that we push this system out of the door, and then of course in the future we will address this a proper way. It's almost like endless process of building a prototype of the system instead of building the real system. And on the other side of things, if we just constantly overdoing the design, just focusing completely on some sort of universal solution type of it just leads to a series of constant reorganizations, rebuilding, restructuring, refactoring everything, making it better all the time. This just leads to just unnecessary stretch of unwanted modifications, which just purely unproductive and sometimes just creates unpleasant drama in process that should be straightforward and streamlined. So organization has to do this despite the changes of personnel direction and management structure. I mean, finding the right balance of all of these design activities. Now, speaking of people, it's incredibly a wrong idea to accept cheap workers that just kind of like low-level programmers, coders, and also consider others as designers, which are basically higher skill workers, but still kind of cheap and altogether just completely dispensable. So the idea is that, okay, we can just fire these people and hire new ones, and they will be easy to train and not a big deal to replace the existing ones. So also this creates this kind of bad chemistry that the coders are not even supposed to attend design meetings and contribute their ideas. They're just a low-level programmer type of staff. And at the same time, the designers are not supposed to concern themselves with actually writing any code. They just make design decisions and contribute their ideas and delegate the tasks to the low-level programmers. So this approach is just completely wrong. Even if somehow it works, it usually produces badly designed large systems with really poor performance, because this is just completely unnatural for the human nature to be expelled from design decisions or not being involved in the actual concrete work, whatever the level of the team members are. So creating a framework within which the people can utilize their talents and skills and contribute ideas and generally enjoy what they're doing is not just the decent thing to have, it also makes a practical and economic sense. So hopefully that's a good set of thinking towards the building of productive teams and having people enjoy what they do. So having the best people in the team and letting them attack the problem just the way they want, sometimes it's a great start, of course, but we still need to focus on the formal design. So as the project makes progress and we start building the software, the focus on formal design, the formalized and proper design, including communication between all members of the design team and programming team, has to be in place. And so the purpose of this process of formal design is to create a clean and simple internal structure. The design of the system needs to be clear, as simple as possible, and as efficient as possible, of course, which kind of leads to the efficiency based on simplicity sometimes. And so overall, this results in a good programming architecture. So the typical development cycle is to be able to examine the problem, create the design. Basically, just largely we can view it as a set of diagrams and descriptions of use cases and so forth. Then we need to identify components, which could be components of classes and individual classes. Then we need to add more of these components and then assemble the entire design. And this is highly iterative process, because as we discover new components, we need to re-examine the problem and also may review some of the design decisions that we have already completed. So universality is like trying to find a Swiss Army knife solution for a set of problems. It kind of leads to the possibility of the design that will never be completed, because you may never find, ultimate, the best possible design. So you need to stick with some kind of a certain cycle. We need to stick with a set of decisions which would allow us to complete a set of tasks, be able to test them, and that's the real progress towards the working system. And from already implemented parts, we gain new experience, and that should contribute to the next development cycle and the next design. So universality should never be the goal. It's just a set of ideals. However, the practicality of what we do probably should take highest priority. So we'd like to have things such as flexibility, extensibility, portability, be able to reuse things in the future, and keep the efficiency in place. So how do we do this? Flexibility can be really achieved through encapsulation of data. So that means that when we build a class that will be the prototype of our objects, all the data members, the data attributes, the values that we store inside this class should be encapsulated and kept private within this class, as opposed to be accessible from anywhere in this system. Extensibility can be achieved through polymorphism, which we will discuss when we talk about classes, and also by applying design patterns that are prepackaged solutions to already known problems. Portability can be achieved by using programming languages which are known to run well based on standards in multiple platforms, and then using their standard libraries. An example would be C++ or Java in many other platforms. And so using something standard as opposed to designing something very, very custom is always the right direction. And reuse efficiency considerations are sometimes making impact on the way we structure things. So instead of for example, designing a large class, okay, with lots of data attributes and lots of operations, sometimes this could be split into multiple classes, right? So we can just split it out to multiple interacting, smaller, more maintainable, and the smaller our concept becomes, more granular they become, there's more probability, the possibility for them to be reused. And also, if we can manage smaller concepts, then the efficiency probably also could be going up, as opposed to just keep adding and adding even more to one concept and just keep making it more, covering more features, as opposed to thinking that this could be another component in the system. So modularization at the correct granularity level is very important.